So I think it's India that's now looking into this with the how much salt is going into the oceans, and as we've got melting caps, this is putting a lot of salt, also known as brine, and yes, it sits down the bottom of the ocean, the more thicker salts. But to think that the ocean is quite stable, not quite. This is still sloshing and mixing in. Then we've got the water that's coming from rooftops, and there's no understanding of how much water is actually being discharged from gutters and stuff. So there used to be a soak away, which put water back into the ground, and this would seep slowly into the rivers. It'd make its way there, and yes, there's also flooding, dumping too much in one area. And again, if the landmass holds the water, how much more quicker is that to evaporate, especially if you've got crops growing in these particular areas. Then we've got so human behavior is, we chop down a lot of trees. Trees contain, we could just say water. We're just going to call it water, keep it simple. Trees contain an awful lot of water. What else have we started doing? Cremation. Again, if a body goes into the ground, it takes a long time for I wouldn't say a long time, but it takes a lot longer than if you burn it, all of the moisture. And again, water is a brilliant thing. It's actually one of the most greatest inventions that naturally form. It can be in multiple states. It's really good for planets. It also has a self-defense mechanism for planets. It's got a self-defense mechanism to life, to a degree. So you can crystallize it, which is freeze it. And again, nice amount of space. But also, if you understand the process of I don't know, that was a bit terrible sort of shape there, but there we are. The whole process of water is really brilliant, really. It acts on so many levels. It's a self-defense mechanism for many life forms. That also the salt in it, the impurity, I guess you could call it that, actually stops it from evaporating too quickly, which helps in atmospheric losses. It's a very interesting process. It's one of the best creations that you can imagine. So if we look at Europa and we'll say that's salt water, okay, can there be fresh water there? It's possible, but it's very unlikely until something happens. Then you're going to need some warmth. But here on Earth, we've been doing some very strange stuff, so life forms. So cutting down trees, and then we burn it, releases moisture. Coal holds on to moisture as well, and when we burn that, it releases moisture. And also to cremate bodies. I'm just going to put bodies down. Or I'm just going to put body, doesn't matter. I'm pretty sure that might be IES, but it doesn't matter. So we've got trees, bodies. These leach the water out slowly, and what it does is it leaches it into the ground. And then the ground, if you're growing crops, holds on to more moisture. So I dare say, if you had fresh water and a thin slick of it over the ocean, then that is going to be exposed to more sunlight, and it's going to be more readily to evaporate. Salt water in itself is a bit more slower than fresh water. Fresh water is fast to evaporate. There's something else that we've been doing. So we've been drilling for water. So Africa, the water layer that was underneath the crust, if it's brought to the surface and drunk, it's not going to have enough time in a hot climate to seep back down, and it's going to evaporate quicker. And then this is adding more water to the planet. So if we were to take all life forms and squeeze all the moisture out of those, and that's including nature, life forms, you'll understand that there's a hell of a lot of water here. And in colder areas, this will rain down and find its way and manage to seep into the the ground levels, and underground rivers seem to hold on to moisture, not really much exposed to sunlight, so it's less likely to evaporate unless it gets close to the core. It might steam, but again, it's so beautiful how it can steam. It can puff the atmosphere for a bit, and it can also shrink it, puff it up and shrink it, puff it up and shrink it. So there's a fine balance. There's something else that we've been doing as well. So if we take a place in the world where we find naturally occurring salt, because there was a, let's say, a prehistoric ocean there, the salt that's there, it wouldn't be a good idea to start putting this on your dinner, because this is going to add more salt. And remember, you've got it coming from the caps. And if this stuff is in a desert, which it usually is, you've got salt on a desert, and then we've got the chemical where you make a chemical reaction to cause salt. Burning is very salty as well. So we've got multiple salts that were not, they wouldn't have found their way naturally into the ocean. So if we were to take all of the salt from the salt flats, I'm not sure, and start adding this to the salt, or in our dinners, or throwing it on a road, we're adding to a process of more salt into the ocean. Now, if you're tracking this and you're looking at how salty it is, look at the impact on when there's more salt into the ocean and there's more river water. It's hard to tell which one is causing this. So we could look at salt and we could look at excess water. So water that would go into the ground here in the UK is hitting a roof, and then it's being fast-tracked to a river, or it's pushing out into a sewer. Either or, it's making its way very quickly into a river. This causes flooding. That's just going to cause flooding. Whereas before it was able to seep down, but we've made concrete barriers, technically. It'd be great if you could make drains that were soakaways. Meh. That would be interesting. When you fast track it to the river, it means that it's fast tracking to the ocean. When it fast tracks to the ocean is exposed to sunlight, and a lot of it, and therefore a level of heat. Then fresh water floats on top. The more saltier levels, deeper you go. This kills the coral reef. Interesting, really, isn't it? And this might stop migral fish from traveling back up. What's the point in doing that? If they're reading a copious amount of fresh water on the top, they might not be inclined to do it, or it could disorientate them. It's like having multiple norths. So when looking at this, let's say the salt water, and then we're going to be looking at fresh water, we got a hell of a mix. So you're getting it from underground in Africa. Britain are drilling it out of chalk. Again, it was captured in chalk, so that was a level that was being held. Yes, you're putting waste products back in, but waste product back into the chalk is not the same as putting water back in. You understand that. If you start adding matter or mud to water in a jar, so if you've got a jar of water and it's this big, and you start adding mud and stuff to it, you either increase the water surface, but it's because you're adding volume to it that's not water, so it gives the impression that there's more water going in, but there isn't. So again, if you were to remove all of those debris and then just inject back that toxic water, I would say possible, but you've got to remove a lot of particles, and then by the time you've done that, you've purified the water, you might as well reuse it again. Interesting. Then what was going in the ground is going in drains. Drains discharge this into rivers. So you're upping more water than there ever has been. So what was naturally able to get from evaporation process, from trees sweating and different things like that, it would have reached a level of about here. But now you're taking it from here, chucking it into a river, taking it from rooftops, no longer using soakaways, chucking it into a river. This is making its way to the sea, and now there's a new line appear, that there's now more water. And now, with there being more water, depends on what's mixed into the water, because salts are often crystallized, and certain mineral content that collects into the water, which then discharges into the river. It's missing out a process which, when water travels through, and it's strange, you could also say the moon is doing this. Doesn't just affect the ocean, that's just more visible, but it's also affecting it through the crust too. And with this pulling, this water is knocking out mineral contents and leaves crystals, and it gathers others. So essentially, it's washing the land. Without that process now, you're then adding more debris into the sea, into the rivers. And usually there seems to be a lot of salt, so a lot of it is manufactured. You can manufacture salt. Plus, with what the caps are leaking out, the last thing in the world you want to do is turn your ocean into the Dead Sea. Because then again, this will begin to impact the life in the ocean. So especially the coral reef. So if either of these, so it's hard to explain in that way, or it's hard to see it, which one it is. Now, is it rising fresh water? Is this causing a problem? I think it is. Because if you've got more to evaporate in a hot spell, well, that's going to self-regulate because it can't hold on to that forever. And then if it hits America or whatever else, the storms are going to be by and large getting worse and worse and worse. And it's going to be bringing more and more water because there is more and more water readily available. So what's the maximum limit of the sun hitting the ocean at a certain area? What is full capacity of the sun's influence on how much water can it evaporate? So if there's this much water, is it only going to be able to evaporate that much? If there's more, when does the sun's influence start becoming where it can no longer evaporate? Where does it start reaching where the sun's influence, how deep do we need to make the fresh water before the sun's influence is like a capacity that it can only evaporate this much water? Anything beyond that, you need a second sun to go more. Each time you add more is going to make the storms more widespread, more bigger, and more devastating for, well, it's going to cause flooding because it's going to be able to hoover up an awful lot. Whereas once it may have just been a little bit of strong winds with a little bit of rain. Then we get technologically advanced. We found ways to make rivers run at full capacity by as soon as it rains, we discharge it back into the ocean. Then we've got to factor in summer. And then what are we doing? More is being taken from the land. Trees are also doing it. Nature's doing it. And if more land is exposed, how much more is that penetrating? How much more is that then squeezing out? How much more is that then adding to the fresh water on the ocean? And then how much does this do for coastal erosion? It seems like a knock-on effect. And then we're changing the pressure in the ocean. If we're making it deeper, essentially, we're putting more pressure on. Does this cause life forms to die? It's basically no different to saying whether we add more pressure in the atmosphere by turning solids into gases that can't go back into solid once it's formed into a gas, which essentially this begins to puff up more and more the atmosphere. And that's never a good thing either. That can make us quite sick. And essentially we're doing this to the ocean. So are we killing the life in this process? Adding more and more salt? Where's their level? Where's their level of how much salt they can take? Where's that pH balance for what's too salty versus not salty enough? And that's interesting. So in parts we're diluting it, and in other parts we're overdosing it in salt. So I think the only way to really track it is to put I don't know, at the end of all drains that are pumping into rivers, is to put a turbine that calculates how much water is discharging into the rivers. Because this gives us a rough idea, and then followed up with a generic turbine, water mill, whatever it may be, so that this can count how much water is passing by, how deep it is, what's naturally passing into the river, and then how much extra are we adding. Because before we had roads, houses, and everything else, there was land, forest, a lot of forest, trees covered the land. Yeah, they were wetlands, but again, when the canopy opens on the tree, when it gets hotter, the canopy opens. When the canopy opens, yes, this is sweating, but it's at a slower ratio than what it was if the light was hitting, let's say, the surface. And then this would have lent over rivers, which would have also protect the rivers from fast evaporation. So if you've got trees either side of the river, there's only going to be a certain amount of time when the sun is going to have maximum influence on that body of water. And it's not going to be enough to evaporate it too quickly. And then we notice that there is an imbalance. Yes, nature caused the imbalance. What was it like without trees? You're starting to find out. What was it like without nature? You're starting to find out. So again, the earth to be covered in full concrete and keep building more and more cities and keep building more and more ways to discharge water, inevitably, in order to move the water away from the cities to stop flooding, essentially it begins to create flooding. That's a very weird phenomenon. It's like you damned if you do and damned if you don't. So in a way to prevent flooding, it might be causing the flooding. So it would then need to look at, is there a way to at least bore down using piles, but instead of put a steel cage in there, but no concrete. The steel cage has got to be a way of, it'd be really decent if we could make an auger that begins to open out really big under the ground. And then if we could line that, if possible, to line that with concrete around the outside to stop it creating a sinkhole. Wow, it's still going to, I reckon, with the amount of heaviness it's going to be. And then keep a steel cage that goes up to a drain in order to make that water go down and create a soakaway further down. Yeah. Again, underneath the city, a few of these are going to be at full capacity, especially if it floods, but it should lower the flood level at least a bit. And what's more, it puts the water into the ground. So therefore, it's going to saturate the ground around. Again, that's an interesting thing to think about. So yeah, I don't know. Let's say if we got the crust, if we could drill down with piling, and essentially be able to make a concrete cage with that, if it's even possible. I mean, how to do that? That's going to be the thing. The auger would need to expand out. That would make the hole, but it could be prone to collapse down on itself, which could cause a sinkhole. So, unless it could have a few thinner piles inside it in order to hold the top up. But how do you get the concrete to sit over here? Could fill it with stones. That's another one. But again, that's still volume. That's an interesting thing, that is. Under farmland? Yeah, it could kind of work. Oof. Even making series of channels like that and then grating them over just to allow the water to sit down and soak out naturally. Anything to stop it going to the rivers too quickly. This is going to find its way to the river, but how long is it going to take traveling through all of the medium being the soil types? And this is pretty good because it's going to knock out impurities. So it could crystallize. It's interesting. It's very interesting. And then definitely with salt, if salt is becoming the problem, that we're moving salts left, right, and center. When we cook food, when we burn it, it becomes salty. Cremating an ash That's salty, and we're also releasing moisture quickly. If you think about it, if it takes multiple years for the natural processes of a body to decompose underground, and bit by bit this is leaching out, it never goes fully dry because of the soil types around it. Perhaps in the coffin it's got the chamber, so it's a little bit more of a slower process. Again, these nutrients are going to be picked up by plants and different things like that. Trees as well. Have you noticed that in cemeteries the trees are really big? That's because of the nutrients that they've got. It's a horrible thing to think about, but it is also true. It's nutritious. And as it's leaching out, I think the trees are sort of taking that essence as well. And then they're controlled evaporating. That's interesting. But if you're burning it and it's done, what, within 9 hours, you've released that moisture very quickly, as opposed to taking multiple years, which is versus a lot of months. The more that humans hold on to water, and when we die, we used to leach it out very slowly. Now it seems to be within, and then it's how many people are dying versus how much water are they holding on to, then how much are they releasing versus the birth ratio. Aye. Plus with the cities. So I think a real way to get a gauge on it is to find out how much we're putting into the ocean, which is into the river, and then how much is going into the ocean. And then is there a way to limit that? Also extracting the salt that we put into the water. This can be done in a series of chambers. If it's going to be getting close to summer and we do one silo, another silo, another silo, these are going to fill up with crystals. We could even make this solar powered so it doesn't bankrupt the grid. And if it's going to take a few months to do so, then while that water's there, it's not being evaporated and rained down on cities elsewhere. And slowly but surely take those salt crystals and save them for winter. Again, that's recycling the salt. How does that look? To recycle the salt. And then human sweat. We sweat an awful lot of salt, and to think that it isn't doing anything. I think you'll only get this on snow, and if you've got a large amount of group of humans and they're all sweating, all of these little sweat droplets that fall down and then they become salty in nature. It also stops you freezing. It acts like an antifreeze. It's a very interesting thing. To a degree. And then what, we wash our clothes. If we've been sweating in clothes, that's changing the pH of the water. So that's more salt. We just overlook the most smallest things, and we're all washing our clothes. So, and then how many humans are there creating an awful lot of salt? And if we're over salting our dinners and stuff with salt that we're getting from somewhere else, do you see how this starts to run away? 1 or 2 humans, not too bad. A few nations, not so bad. But if every nation is doing this, that's huge. And then we're salting baths. That's another one. Doesn't seem like it's massive, but bit by bit, this begins to build up. Are we slowly turning our water into salty water? Which, yes, might stop it from evaporating very quickly from the ocean, but it tends to fall down, doesn't it? Yeah. Interesting. Anyway, it's just something I was just sort of thinking about. Someone's paying an interest into this. And again, what does this have an impact on life? What does it have an impact on storms? What impact does this have on flooding? So, just lots of different things like this. And does it run away? It seems unchecked because it was never a problem, and now it's reaching that point where it's becoming quite a problem, and the rivers are seeming to be at full capacity. We've stopped a lot of rivers from eroding, and then because there's a large volume of water and it can't erode the sides, which usually causes the rivers to fall back into themselves anyway, and this keeps the bottom from getting too deep. When the river gets too deep, it starts cutting channels underneath it. Certain areas of the river, it's not all the same soil content. and sediment and rock content. So we often think that the river is the same all the way down. Well, if we've got a river that's like this and there's certain medium here, and then there's another rock type here and another soil type here, which one is going to erode quicker? And if it's this one, it will undercut. By and large, that's not too bad, but it's when you get leaf debris fall into here. It makes a pocket for leaf debris, and then can this run away by making methane, which then adds in its own right increases CO2 as well, doesn't it? When that becomes all boggy. Whereas before it might not have done that, it might be a bit more even, it might be a little bit undercut. And now we've got a large amount of water coming down and it's really heavy. The heavier it is, it's more able to push on these bits. And that's okay, but when the water drops down, it's no longer strong enough to move this stuff further out to sea. So it doesn't break down scattered, and it concentrates, and then you've got pockets of gas. And what is it mixing up? That's interesting. That's a very interesting thing. But yeah, no, water and salt. And then with the more and more here, we tend to favor profit over getting it into the river as quickly as possible. And then that's going to run away. That has a knock-on effect. And then the more houses that are connected, and then as opposed to putting a soakaway in, because you'll only get £5 to give to the water company, now it's more profitable to stick it in a drain. Yeah, and that's where profit begins to tends to fuck the environment. You see what I mean? Whereas the soakaway, especially around farmland, it'll keep it very moist, very good. Better crops. It holds it over the summer months as well, so there should be less to drop in an instant. Spongy soil. Interesting. If it was like a sponge, hey? Be able to soak that all up. So yeah, I don't know. I would be looking at the ratio, but yeah, when you look at this with a little bit more scrutiny, we've removed a lot of trees, and they are releasing moisture. Doesn't seem like a lot, but they hiss a lot when they get burning. Cremation. Then we are drilling water from, let's say, underground. So that wouldn't happen naturally. If we are moving salt from desert areas, that's not great, because, when's it ever going to rain in a desert? When was it ever last recorded that there was any rain? And then how much of that salt has been washed away? Well, not a lot. And even if it was, it's a very slow process. It's unlikely to rain there. So it sort of acts like a self-defense mechanism. So we got to look at that and think, should we be taking salt from there and maybe using it in society? And the answer should be no, because while it's there, it's actually protecting the ocean. And then I wonder about algae blooms as well, especially in Florida, wasn't there? There's a lot of problem with algae blooms. Now again, if we get a lid on these things, does that subside? And that's something else that's fascinating. And you only find out later on. An algae bloom again, isn't that quite? It stinks. We see this usually in stagnated water. I appreciate that. Sunlight and stagnant water seem to create this algae bloom. So if you had a new river put into these Florida areas where the water was pushing out at these areas, I think that would get a lid on it, but that's a temporal fix. That sounds really weird, doesn't it? To create a sort of stream that runs in, so it's constantly pushing in water, which then is pushing out, and it forces the water to move. That stops stagnation, but again, it's got to move. Temporarily would be having solar panels connected to high pumps that push the water into this area, and another one that pushes out, so it causes the water to circulate in these particular areas. That would work. It's temporal, and the more light there is, which is more predominant to cause the algae bloom, the more these pumps get working on floating solar panels, which could look beautiful at the side. Who knows? And then it pumps that water in. That's all it needs to do, is really pump it. And then the colder it gets and the less sunny it is, then they will, so that's really good. So the solar panel acts like this works to combat algae, I think, really well, to be fair, because the algae is going to bloom in stagnating areas, so the water is going to be very still. So the more sun there is, the more chance of algae bloom. So if you've got a pump that's connected to a sensor, which would be the solar panel, the more intense the light is, the more harder these pump. And as a result, it will push more water into these areas, and then at the same time, it's pulling the water out. So fresh is making it in, and the old is being pushed out. Yeah, that could kind of work. Yeah, because that keeps the water moving. Hence why rivers, I think, when the more they move, and then when you've got these underpits like this, it causes more algae bloom. So the algae is more readily to flourish in these areas. Which again, if that didn't usually happen and it was eroding a little bit more different than this, then that would keep the rivers pure. So we're adding more algae to areas, which could be running away with adding more carbon. I'm not sure. I can't be sure. And plus they've got something to feed on, the dead leaf matter and stuff like that. Aye. Okie dokie. So that sort of knocks that balance a little bit. So I wonder what you could fill these with, these prone areas. And again, throughout the whole year, torrential rain and April showers and whatnot, that medium should still stay there. That's the only way to really see it, isn't it? When you put something there. If you could fill it with gravel and add little trackers inside it, I mean, that would give you an idea. And then is it about when the water gets like nearly bursting the banks, it then starts to move all of this stuff out of that pocket, which then leads to leaf debris filling in there in the summer months, because we have the end of winter, or the big stuff that's been washed downstream because it begins to erode. Aye. Then the current of the river begins to slow down and the debris get pushed down, and then they fall into this bit because they become waterlogged. Then it starts getting hotter. As it's getting hotter, I think that's then feeding the algae. That allows the algae to bloom, which might not have necessarily occurred. Well, if only you could see it under rivers, really. Be able to have an MRI machine looking at rivers. That would be interesting. There's a hell of a science going on underneath that, with all the current and everything else. And then this has a knock-on effect. Interesting. Very interesting. Is there any more I want to touch on upon that? No. First we'll probably be measuring it. Because something flipped. Something twisted. Something happened. And I think, for here in Britain I've noticed it, it's the reduction of soakaway. More drains in rivers to connect to rivers. Then there's the natural leaching into the river from the bankments. The water's finding its way to the river. But it's bit by bit. It's slower, more trickly, because the water's got to make its way that way. I wonder if this is affected by moonlight as well. Yeah, it's the salt in it. I do think the moon is lifting the crust slightly as well, which also creates a ripple that sort of mounds up and sort of pushes the water. We just can't see it because it's happening in the crust. You can only see it when we look at the ocean. And if it's in a still body of water, I just don't think we've got the eye to see it rise one side and the other when the moon is coming over, because it does it so gradually. I think it's bulging more one side than the other, because I think it lifts the crust. Interesting. Interesting, which then Europa can help solve a lot of things, can't it? Because that must really be moving that underneath there. If it is salt water indeed. Yeah. Anyway. And then if it is about the saline is too much, then this can be removed temporarily and then stick it on the deserty areas, keep it there. It's unlikely to rain. It's unlikely to find its way back to the water. It's unlikely to make its way back to a river. So it's not like it's broken, and yeah, it can be fixed. And then how would that look going forwards? That would be nice, wouldn't it? Sort of temper the climate a little bit. Is it possible? Yeah, I think it is. Yeah, little things that happen in life, although they're very small and insignificant, they seem so dismissible until we add this up across the world. That the environment affects our behavior and what we do affects the behavior of the environment. That's weird type of duality. I don't think we have psychology inside planets, but we got sociology. So yeah, I don't know. It just seems so mundane, doesn't it? Cremation, you wouldn't think it, would you? You just wouldn't think that that's what that is doing. What are the semantics at play there? Oh, with fast track release of moisture. And how many people are being cremated? And then put this on a graph. If there's lots of these things that we're doing, salt baths, and I don't know, I once saw a product that said it had salts from the Dead Sea, and I'm thinking, have we moved that salt from there? Which, would it make it anywhere else? Well, no, because it has gone past the point of there's nothing more to evaporate. The sun might not be strong enough to evaporate any more from there, hence why it's so salty. So it keeps the moisture there. Interesting. And then we're moving that, putting it in a bath, and we forget about it. Like if we pull the plug, that's all then going where? It's going to make its way to a river, and then it's going to make its way to the ocean, or somehow. And then that salt that was once locked in the Dead Sea has now made its way to the ocean. So there's another one. So products. Aye. Which doesn't mean you have to stop selling the product. It probably means more like, can we remove the salt from it? And then it becomes a mineral content, but not salt minerals. God, just little things like that. It seems so innocent, doesn't it? But then when we factor in how successful, and it is, businesses are successful, they're established worldwide, and then if we can get this into every supermarket and it's at every single shop, and then a lot of people are buying it to the point that it's sold out, what looks like a little appears to be a lot, and then that a lot of moving that salts from that area now make it into a place where they never naturally would make it. It would be like humans grabbing a cup of salty water from that place and just going and chucking it in the ocean, yeah? Make a wish. I wish this has no impact. But yeah. Yeah, interesting. Interesting behavior on this, isn't it? It is. I just think we need to look at sociology a little bit more closely. Yes, maybe psychology works really great for inside human minds and stuff, but I don't know. Is the planet psychology or is it sociology that our behavior affects the environment? That's And then does that come from internal? I don't know. And then the environment can affect our behavior. God, it's so reciprocal. Using not psychology but sociology, and then our psychology, if we're always looking at that, I don't know, just sort of look at these things, just the way it all sort of neatly comes together. Or maybe it's just because I want it to, I don't know, whatever. Either it's wrong and it is, then it is, but it feels too right to be wrong. That's the weird thing. It feels like a lot of things that pan out, and then if you put this on a graph, and then you put the trees that have been cut down, coal has been burnt, that's, again, it's not a problem to burn coal overly. It may well be, yes, global stuff, I'm not on about that, but there's a small amount of moisture that it locks. It releases this because it fizzes, and it's very steamy. Only when collecting this moisture from coal, yeah, you notice how wet it really is. If you bend the chimney pipe and then start collecting the moisture from that, it's interesting. You get quite a bit for a few bags of coal. It smells a bit like bacon. It's kind of weird. Well, there's this weird smell. There's some of the wood as well. It also drips out resin, but also an incredible amount of water. So place that to a graph. Burning bodies, place that to a graph of how much water is expected on average to lose from a body. And then we've got to have two graphs. So we've got one graph where we're analyzing how much moisture is being released from a tree burning, from body burning, how much we're taking from underground. And then you need another graph which states that if we'd have done it the old way of burying, switching from one to another source of heating, I guess, is another way. And then we got another one where we add the drains. That needs to be added to a graph, because I think that's then when you begin to see something then. What happened before versus environment in factors that happened. And then these things together, which seem on their own independently, they seem like minute. But when you stack them up, that's then when it reveals itself. And then where's all this water coming from? Here. Then slowly but surely, if this behavior carries on, what's the trajectory? Well, if we oversalt the fresh water, do rivers stop, have enough moisture in them to flow without this trickling in? And then do the rivers then begin to dry out? That's worst case scenario. The other one is, do we have enough water to evaporate? Because the ocean, again, and this causes erosion as well. Has erosion started metastasizing since these behaviors? When did this behavior start? Versus what have we noticed in X amount of years of erosion? Has it got worse? And then does it then start to fit the trajectory of the graph? That's the thing. And then it's like, aha. Then yes, we do have the power to fix that. Soakaways, this one, that one. So yeah, interesting, isn't it? Very interesting. Yeah, I'm going to leave it here. I think I've explored a little bit more on that. So if it helps you in your studies, and then we could look at the coral reef as well. I mean, then how does that look? And yeah, because the last thing we want to do is oversalt the oceans and then lose a lot of marine life. Because after all, you could say, is it overfishing that's diminishing the marine life? Or is it a factor of overfishing because the numbers have got smaller because we've oversalted the ocean? And it seems a really baffling thing that many humans could do that. And I think we don't give ourselves enough credit. Humans working together in this manner, whether we are consciously working together or unconsciously working together, isn't it amazing what we can do? Even when we're not aware of it. Look at that. We can move so much fucking salt that we can Gee me, we really can impact this. So yeah, it reaches a level of balance, I think. And then does this pose a question? Do we need more healthier food? And not because it's healthy in a sense, because it is, but because of how much moisture does that hold, as opposed to making chemical food, as opposed to making fresh food, whatever that may be. It's still going to store the moisture. Interesting, very interesting. Anyway, I'm going to leave this one here. I think I've prattled on enough about this one, but there you are.